The 3T3 neutral red uptake phototoxicity test is a cell-based in vitro assay utilizing a neutral red endpoint to assess the phototoxic and cytotoxic potential of a test substance through evaluation at multiple concentrations in the presence and absence of UVA and visible light. Phototoxicity is defined as a toxic response from a substance applied to the body which is either elicited or increased after subsequent exposure to light, or that is induced by skin irradiation after system administration. The steps shown in this video are IIVS's interpretation of procedures described in the Organization for Economic Cooperation and Development Test Guideline number 432, 3T3 neutral red uptake phototoxicity assay. The procedures shown in this video were performed at the benchtop for demonstration purposes only. All assay procedures except the UVA dark exposure should be performed within a biological safety cabinet using aseptic techniques. The 3T3 cells are seeded into 96-well plates until they reach optimal confluency. The cells are treated with a dilution series of the test substance and then exposed in the presence and absence of UVA visible light. Test substance treatments are removed and the cells are incubated for 24 hours. Viability is assessed using the neutral red dye. The neutral red is extracted and the amount of neutral red is measured using a plate reader. Frozen stock cultures of bulb C3T3, clone A31, mouse fibroblast cells are obtained from a reputable cell bank source. The stock cultures are reconstituted and maintained using good cell culture practices until use. The cells are routinely passaged by trypsinization every 2 to 4 days to maintain proper cell growth, confluency, and morphology. Cells to be used in the assay should not exceed 99 passages since the sensitivity of the cells increases with age. The cells are bathed in culture medium, supplemented to contain newborn calf serum, and maintained at 37 degrees Celsius and 5 to 7.5% CO2 in a humidified atmosphere, also referred to as standard culture conditions. When the 3T3 cells are ready for use in the assay and have reached the appropriate cell density, they are seeded into the 96-well plates. To begin seeding, the cell culture flasks are examined for proper morphology, growth, and confluency. The growth medium is aspirated from the flask, the cells are rinsed with a calcium and magnesium-free buffered saline solution, the rinsate is aspirated, and then trypsin is added to the cell culture flasks. Cells are incubated in the presence of trypsin until the cells detach. Growth medium is added to the flask to inactivate the trypsin. The cell suspension is triturated up and down to achieve a single cell suspension, and then the cells are counted. A cell suspension of 100,000 cells per milliliter is prepared in growth medium, and 100 microliter is added to the interior wells of the 96-well plates. The outer wells receive 100 microliters of growth medium. 2 plates are seeded per test substance, and 2 plates are seeded for the positive control. The plates are then incubated for approximately 24 hours under standard culture conditions to achieve a confluency of greater than 50%. A solubility assessment is performed to determine the appropriate solvent to use in preparing the dilutions of test substances. Ideally, the dilutions will be clear and precipitates avoided. Here are examples of a range of solubility results. The test substances may form oily droplets or a biphasic dilution, large particles that do not fully solubilize, a homogeneous suspension, and finally a clear solution. Prior to testing in the phototoxicity assay, the solubility of the test substance is first assessed in a buffered salt solution, such as Hanks balanced salt solution, HBSS. This is a solubility assessment for a test substance that is aqueous soluble. HBSS is added to pre-weighed test substances to achieve a 2x dosing concentration of 2,000 micrograms per milliliter. The highest tested concentration, as outlined in OECD Test Guideline 432, is 1,000 micrograms per milliliter. Since the test substance is soluble in HBSS, it will be selected to prepare the test substance dilutions. In cases where the test substance is not soluble in HBSS, an intermediate solvent like dimethyl sulfoxide or ethanol may be used. Here is a test substance that is not aqueous soluble, requiring the use of an intermediate solvent. When using an intermediate solvent like DMSO, the test substance is diluted to a 100x concentration of 100,000 micrograms per milliliter. If the test substance is soluble in DMSO or other intermediate solvent, further dilution into HBSS must be assessed to determine solubility. 40 microliters of the 100x dilution in DMSO is transferred to 2 milliliters of HBSS to produce a 2x dosing concentration. Additional measures to solubilize the test substance, such as heating and sonication, may be considered. Once a suitable solvent is determined, the pH value of the highest dilution in HBSS is measured to ensure that a neutral pH has been achieved. Approximately 24 hours after seeding, the plates are removed from the incubator and examined under a phase contrast microscope for proper confluency, distribution, and morphology. By this time, the 3T3 cells should have formed at least a half-confluent monolayer in each well. The plates are labeled with the test substance, solvent, dosing concentrations, and irradiation condition. The medium is decanted, and the plates are rinsed with HBSS and decanted again. The plates are carefully blotted dry, and 50 microliters of HBSS are added to the inner wells containing cells. 100 microliters of HBSS are added to all outer wells to maintain humidity during plate incubation. The plates are returned to the incubator until dosing is initiated. The test substance is serially diluted in the appropriate solvent as determined in the solubility test. Test substances that were soluble in HBSS are serially diluted in HBSS at a constant dilution factor. Once the highest concentration is prepared in tube 1, the dilution is vortexed, and a specified amount from tube 1 is added to the solvent in tube 2. Again, the tube is vortexed and a portion is added to tube 3. This process is repeated until all dilutions have been prepared. At least 8 concentrations of the test substance will be prepared. In some cases, where the test article shows phototoxicity, additional doses may need to be prepared in subsequent trials to address the range of dose responses. If there is any noticeable precipitation or cloudiness, the dilutions may be heated and sonicated prior to dosing. For test substances that are soluble in intermediate solvents like DMSO, the test substance is diluted in the intermediate solvent to a 100x concentration. The highest 100x concentration for this assay is 100,000 micrograms per milliliter. A serial dilution of the test substance in DMSO is prepared. An appropriate amount of the highest dilution in tube number 1 is transferred to the tube 2 already containing DMSO. This process is repeated until all 8 100x dilutions have been made. If any precipitation is observed, the dilutions may be heated and sonicated to increase solubility. A predetermined amount from each 100x DMSO solution is transferred to tubes containing HBSS, reducing the 100x concentrations to 2x concentrations. For example, starting with the lowest dilution, tube number 8, 40 microliters of the test substance diluted in DMSO, or 100x dilution, are transferred to the corresponding tube labeled with the number 8, already containing 2 mL of HBSS, or 2x dilution. This process is repeated until all 100x dilutions have been transferred to the corresponding tubes containing HBSS. The dilutions in HBSS may be heated and sonicated to increase solubility if precipitates are observed. For test articles requiring an intermediate solvent, a solvent control dilution is prepared. The concentration of solvent will remain the same in the solvent control as in the test substance dilutions. In our example, a 2x solvent control containing 2% DMSO is prepared by diluting 200 microliters of 100% DMSO into 10 milliliters of HBSS. Once we've prepared the solvent control and our serial dilutions of the test substance, the dilutions are transferred to reservoirs to facilitate dosing. The solvent control is transferred to a single well reservoir, and the dilutions are transferred to a pre-labeled 8-channel reservoir. Starting from the lowest 2x dilution in HBSS, the tube labeled 8 is vortexed, and the entire contents are transferred to the reservoir labeled number 8. This process continues until all of the 2x dilutions in HBSS have been transferred to appropriate channels in the reservoir. Once all of the dilutions have been added to the reservoirs, the applicable plates are removed from the incubator. First, the solvent controls are dosed with 50 microliters of the appropriate solvent control. In this example, the test substance was soluble in HBSS, and therefore 50 microliters of HBSS are added to the wells designated for the solvent control. The solvent control wells are the inner 6 wells of columns 2 and 11 on the 96 well plate. Next, the plate and 8-channel reservoir are rotated so that the dilutions align. The 2x dosing dilutions are mixed by pipetting up and down in the 8-channel reservoir. 50 microliters of each test substance dilution are dispensed into the corresponding wells on the 96 well plate, already containing 50 microliters of HBSS. This yields a final concentration of 1x of the test substance in solution. Each test substance and the positive control are dosed onto a pair of 96 well plates, one plate for cytotoxicity and one plate for phototoxicity assessment. The plates are returned to the incubator for a 1-hour incubation period at standard culture conditions. Each assay trial includes a positive control, chlorpromazine, tested concurrently over a range of 12 doses. A historical database of the chlorpromazine results is retained and used as a comparison to individual assay results to ensure proper assay performance over time. The OECD Test Guideline 432 suggests solar simulator light sources for the irradiation step of this assay. A solar simulator equipped with an H1 filter that allows emitted light of approximately 320 to 800 nanometers while attenuating UVB light less than 320 nanometers is used. After the 1-hour incubation at standard culture conditions, one 96 well plate dosed with the test substance is placed under the solar simulator. The other plate is placed under the same temperature conditions in the dark. Cells are exposed to 5 joules per centimeter squared of UVA light. When the light output is 1.7 milliwatts per centimeter squared at a specific distance, the cells receive 1 joule per centimeter squared every 10 minutes. In this case, a 50-minute exposure is equivalent to 5 joules per centimeter squared. The light output is verified using a calibrated UV light meter. After the 50-minute exposure, plates are removed from the light or dark conditions, and the test substance is removed by decanting and very gently blotting the plates. Care must be taken at this step since blotting the plates too vigorously may result in cells dislodging from the 96 well plate. Plates are rinsed with a buffered solution. The rinsing solution is decanted, and again the plates are blotted very gently to minimize cell loss. Culture medium is added to each well of the 96 well plates, and the plates are returned to the incubator for a post-incubation period of approximately 24 hours. After approximately 23 hours, the plates are removed from the incubator, and the cells are examined using a phase contrast microscope. Changes in cell viability and morphology are noted. The levels of cytotoxicity are compared to respective solvent control wells and may be used to support the viability results. Plates are returned to the incubator until the neutral red uptake endpoint. A neutral red solution for the neutral red uptake endpoint is prepared from an aliquot of a neutral red stock diluted in warmed culture medium. This solution is filtered through a 45 micrometer filter to remove any undissolved crystals and used within 30 minutes of preparation. Plates are then removed from the incubator, the culture medium is decanted, and the plates are blotted on absorbent towels. The plates may be rinsed with a buffered solution, the rinsate decanted, and the plates blotted on absorbent towels. The prepared neutral red solution is added to each well of the 96 well plates, and the plates returned to the incubator for 3 hours. The neutral red is a vital dye used to measure viability. Neutral red is an uncharged dye that passively enters into cells. Once in the acidic lysosomes, the neutral red becomes charged and trapped within the lysosomes. Healthy cells are able to retain the neutral red dye, while cells which have become damaged are unable to retain the neutral red. Prior to the end of the incubation with neutral red, the plate should be observed microscopically for neutral red uptake within the cells and to assure that the neutral red hasn't precipitated out of the solution, causing crystals. After the 3-hour incubation with the neutral red solution, the plates are removed from the incubator. The neutral red solution is decanted, the plates blotted on absorbent paper, and rinsed with HBSS. The HBSS is decanted, the plates blotted, and then a solvent containing 50% ethanol, 49% water, and 1% acetic acid is added to all wells of the 96 well plates to lyse the cells and release the neutral red. The neutral red is extracted and the solution is homogenized by shaking the plate on a plate shaker. After shaking, plates are read using a spectrophotometer at an optical density of 540 nanometers. The raw data are captured for analysis. The Phototox 2.0 software program was developed by the Center for Documentation and Evaluation of Alternative Methods to Animal Experiments, also known as ZBET, specifically for this assay. The software, as well as instructions for use and data files from the validation trials, can be downloaded at OECD's website. Dose response curves are generated after inputting raw data and dosing concentrations into the program. Viability is calculated at each concentration. The concentration where the neutral-red uptake is inhibited by 50% or IC50 is calculated for both the light-exposed cell cultures and dark-exposed cell cultures. In addition to IC50 values, the Phototox 2.0 program calculates two measures of phototoxicity: the photoirritancy factor, or PIF, and the mean photo effect, or MPE. The PIF is determined by comparing the IC50 values of the cells exposed in the presence of light as compared to the cells exposed in the absence of light. The PIF is useful when IC50 values are obtained from both the light and dark exposed cells. The MPE compares the dose responses over a range of concentrations. As outlined in the OECD test guideline, test substances are considered as non-phototoxic, probable phototoxic, or phototoxic based on the PIF and/or MPE values. The mean optical density value, or OD value for short, for the blank outer wells was obtained. The corrected OD value for the solvent controls and test substance dilutions were determined by subtracting the mean OD value of the blank wells from the raw OD values from each well. The percent survival, or relative viability, for each well was calculated by dividing the corrected OD value for the test substance dilution by the mean corrected OD value of the solvent control wells. The relative viability was plotted against the test substance concentration. Each plate is evaluated individually, and then the light and dark exposed plates are compared for a phototoxicity analysis. Based on the results of this assay, a test substance is non-phototoxic and non-cytotoxic, phototoxic and non-cytotoxic, cytotoxic and non-phototoxic, or phototoxic and cytotoxic. According to the prediction model presented in OECD Test Guideline 432, a test substance is considered non-phototoxic if the MPE is less than 0.1 and/or the PIF is less than 2.0. A test substance is considered a probable phototoxic if the MPE is greater than or equal to 0.1, but less than 0.15, and/or the PIF is greater than or equal to 2, but less than 5.0. A test substance is phototoxic if the MPE is greater than or equal to 0.15 and/or the PIF is greater than or equal to 5. Laboratories initially establishing this test method for use in their facility should consult Table 1 of the OECD test guideline for a list of proficiency chemicals. These chemicals can be used to demonstrate technical competence in the 3T3 phototoxicity assay prior to submitting 3T3 phototoxicity test method data for regulatory hazard classification purposes.